Hello friends, this is an introduction to 3D with Svelte. I will show you how to spice up your boring sites with 3D and Svelte and maybe show you some cursed code. Hello friends, welcome to 3D with Svelte. By the end of this post you're going to learn how to spice up your boring sites with Svelte, and by the end you're going to learn how to create this awesome scene with this cute ghost. I mean spooky ghost, woo! I hope you're excited as I am, so let's get started. So what is Threlte? Threlte.js is a popular 3D library for JavaScript that abstracts having to write low-level graphics code yourself and lets you create anything from immersive 3D experiences to games in your browser. I want to show you the awesome things you can do using Threlte.js, so here is an example of a portfolio that uses some GSAP scroll magic with Threlte.js. So if you can see here is a room, and if you scroll further out, you can just see the awesome example. And you start scrolling, and this is really awesome. And you can see this, and this is really complicated to make yourself, but it's possible, right? And I guess it's not even that complicated. There's like an 8-hour tutorial on this on YouTube if you're interested. It's like really, and you can see these things, these are like using shaders, which is also a spooky term maybe. So yeah, this is really awesome. I really love this part. And then it scrolls this text. And yeah, I can go on forever basically. And you can also change the theme so it can be dark, and it's really awesome. And also here's a game, so you can press start, and you can control this car. And I'm the best gamer ever. This is hard. But yeah, you get the point. And you might have heard of other libraries for Svelte using Three.js, such as sveltekit, which was made by Rich Harris, but Rich Harris is busy with sveltekit right now, so basically this was just a proof of concept, and I think it's even abandoned at this point, because what's the point? Because we're going to use Threlte. That's even blessed by Rich Harris. But there's another awesome library, Svelte, but the problem I have with this, it doesn't even have documentation, which is very surprising to me. Or maybe I'm bad and I can't find it, but yeah, there's really no documentation. So the one I looked at, Threlte, is the most feature complete, very active. The Discord is very friendly. You can ask anything and you're going to find an answer in seconds. So yeah, this is Threlte, and it's really awesome. I really love the documentation and care to attention and detail. So here is the man himself, the leader of our church, Rich Harris, blessing Threlte. So this is really awesome. And I also have a small ask of you. Please go to the Threlte GitHub and give them a star because they deserve it. So go to Threlte and show your support. It's free, doesn't cost anything, right? Just give them a star and join the Discord. So you might be thinking, what is even the purpose of Threlte? Threlte is basically just a component library or wrapper around Three.js, so you can write declarative code using Svelte, but this might not mean anything to you. What is even declarative? If you go to Three.js, for example, to their documentation, and here they lead you through an awesome example, and basically, let me just zoom in. See if this is responsive. Oh, it's not. Okay, you'll have to suffer with me. So basically, here is everything you have to do. You have to define the lights, the width. You have to keep track of everything yourself. Let me just see. Yeah, you have to define the renderer, the scene. And this is very imperative code because you're giving an instruction for every step. But imagine if you could do something like in Svelte in a declarative way, which would be way easier. But let me just drive this point further to home with you, because declarative imperative sounds like something spooky, but it's really not. So for example, let's say you want to make a title. So you can say, using regular JavaScript, you can say title, document, create element, and then you can say h1. And then you have to say title, element, inner text. Let's say, for example, hello. And let me just rename this. So I can say title element. And then you need to append it to the body. So you can say document, body append, title element, and you get the hello. This is basically what imperative means. You're giving every instruction for what you want to do. But using declarative code, on the other hand, you just state the desired outcome. So instead of doing this, because Svelte is a declarative JavaScript framework, we don't even need all of this, you can just declare what you want. So you can say hello, and Svelte under the hood does all of that imperative code for you, and that's basically what it means, imperative versus declarative. Three.js is powerful and might be intimidating if you've never done 3D or game development before, but it's worth learning as the knowledge you gain transfers even to web development. If you want to learn more about Three.js and 3D in general, I encourage you to read the Three.js fundamentals. This is going to introduce you to shaders, material, and etc. everything regarding 3D, and this is really an awesome resource if you want. Another awesome thing you can do is play around with the Three.js editor, so you don't have to even download and learn Blender, so you can just go to the editor, and if this is your first introduction to 3D, then for example, you can just, let's say the sphere. Here's a sphere. And it's dark because we don't have any light, but let's just raise it up. So the red arrow is the x-axis, the blue arrow is the z-axis, and the green arrow is the y-axis. And you can just add, for example, an ambient light. This is going to light everything evenly in the scene. This is a cheap version of global illumination, if you're familiar with that. But let's add a directional light, and boom, you have something on the screen, right? And you can just play around here. You can translate this to Three.js if you want. This is a way simpler approach, in my opinion, to get started. And I also want to strongly emphasize that, for example, if you're going to Threlte and you're maybe reading their documentation, you're like, okay, introduction, getting started, and you might thinking that this is sparse, and it might be because it's still under development, but the job of Threlte isn't to re-implement everything from Three.js or to teach you Three.js from scratch, right? The way you learn Three.js is from the Three.js site, so reading the documentation, the examples, other tutorials. Just because you're using Threlte doesn't mean you have to search for specific Threlte and Svelte content. You can watch any Three.js tutorial and translate that concept to Threlte. Let's talk about the setup. I'm using a regular sveltekit project with TypeScript, which is optional, and then you just initialize the sveltekit project if you want. I'm going to use pnpm, but you can use npm. npm create svelte, then install the dependencies, and then run the development server. And now I'm going to install the Threlte and Three.js dependencies, so you can go to your terminal. I'm just inside a project, then you can say pnpm I, and then you can say Threlte core, and then you install Threlte extras and Three.js. And then you can just install that, and additionally, if you need TypeScript types. Awesome, and then I can say pnpm I, install as a development dependencies, types 3. So these are the TypeScript types for Three.js. Because Three.js is an older library, so it wasn't built with TypeScript from the ground up. And the next step you have to do is not that clear to me, and I try to get answers, but from what I understand, Vite ignores transforming dependencies when using server-side rendering to speed things up, but in this case we don't want it, and we need to specify some packages like Three.js and Troika 3 text for using text, that they shouldn't be externalized, and Vite should process them instead. So inside your editor, I'm going to close the terminal, Control P, and let's just look for Vite config. In my case it's Vite TS, but if you're not using TypeScript, it's going to be JS. And you can just add server-side rendering and no external, and that's it. Basically, you can just paste this over and you're basically done. And now run the development server, so you can say run dev. And your site should be available at port localhost 5173. And I don't have anything in my page. I just have a layout that I added. You can do that if you want. I just made a scene here and I'm styling this, so I'm giving it an absolute positioning, and I'm going to set a radial gradient background if you want. So basically that's the setup out of the way, so you can focus on what's important. Let's start by creating our first scene. In your editor, press Ctrl P and you can start typing page, and this is the only page in the project. So let's start by importing Threlte and Three.js. So we can type script. And then I'm going to do a namespace import all as Threlte from Threlte core. And I prefer this because when you do something like this, you type canvas and then you're going to constantly be fighting imports in your code editor, and I often do the wrong one from Three.js and etc. So it's way easier to do a named import like this, and then you know where it's from. You can say Threlte canvas, and this is way easier in my opinion. So yeah, this is why I like to do this. So you can say import all as Three from Three.js, and then we're going to need some math helpers. Import all as, to say utils from Three source math and math utils, and this is going to be it. Everything that happens in your scene is inside a canvas object, so we're going to say Threlte canvas, and then I'm going to make space. First I'm going to add a sphere, so you can say mesh, actually it's Threlte mesh, and then I can complete it like this, and let's give it some attributes. So we're going to need the geometry. And for this one, you're going to need the Three.js material. So you can say new Three sphere geometry. And now we're going to pass it radius, width, and height, the amount of segments. So you're going to say 4, 64, 64. And then let's pass it a material. So again, this is going to come from Three.js, free, and we're going to use a standard material, mesh standard material. Awesome. And now we're going to just give it a color. We're going to say white, but you're going to see the problem right now. So it's black because first we don't have any lights, and second we are zoomed into the object. So let's add a camera. We can say Threlte perspective camera. You also have an orthographic camera. And let's do it like this. And I'm going to set a position for the camera. Just do it like this, and you see why I'm doing it like this. So I can say position. This is important. So the Z axis is zoomed in. So we can say, let me see, X20, Y20, and Z is also 20. And you can also give it a field of view, which I put at 50, I think. And now this should be slightly better, but we don't see anything because let's add orbit controls. And orbit controls are going to let us rotate around the object and see it. So thank you, editor, but I really didn't want you to do it. So we can say Threlte orbit controls, and then we can do it like this. And let me just see. Oh yeah, it imported. It also does weird things like this. Yeah, so let's just save it, and you can see our sphere here, and we don't have any material, so even if I rotate it, it doesn't look like anything because it has no light, so you don't really see the dimensions, right? So first let me add an ambient light, and it's going to be basically like global illumination if you're familiar with that, but this is just a cheap man's global illumination. So I can go here and I can say Threlte ambient light, and sometimes you don't get auto completion, but that's fine. And I'm going to close it, and let me just see, I'm going to say white, even though I think this is the default. And then let's just save it, and yes, it's going to be the default. So we can even reduce the intensity. We can say 0.2, and it's going to be dimmer. And you're thinking, okay, how am I going to see anything? And we're going to add a directional light that's basically like a sun, and it also casts a shadow. So we can say Threlte directional light, and this is beautiful how declarative code is way simpler than writing the imperative version. But yeah, we have it like this. So we can say color white, which is again default, but and you're also going to mostly see all the time hex color, so you're going to see something like OX and then whatever FFA, but I'm just going to use my web developer colors. Thank you very much. And I can say intensity is going to be 2. And now if you save it, we can see some dimensionality, right? And now since we have the orbit controls, we can see it all works. So we can just orbit around the object or the mesh, right? So for the directional light, let me just go here, and I can say position, and I can say for directional light position X is 10, Y is going to be 10, and awesome, that's it. And that already looks beautiful to me, chef's kiss. So let's work on by adding the floor. So this is our sphere, and again, we're going to use Threlte mesh, and then let me just close it like this. Let me just copy over these two lines, so I don't have to type everything out. Instead of sphere geometry, this is what you can learn from the Three.js documentation. If you just look at it, there is a plane geometry. And then for the plane geometry, it's just 20, 20. So if you see here, you get the width and height, right? So it's 20, 20, but it's going to be on the wrong side, and we need to rotate it 90 degrees. And you see, we can just say, let me just see. For the material, you can also supply options. So here where we have a material, where's the color? Let me just make this more readable. Color, white. Even though we're not going to need this in a minute, I'm just going to say side. And then it's free double side, right? And then let me just do it like this. And now we can see it from both sides. Yeah, let me just say that this should receive a shadow. So this is how our light is going to work. And now for the rotation, this is something very interesting because in 3D in general, you use radians, but you can use degrees, but you have to convert them. So let me just say rotation. And then if you do something like this, you might be saying, hey, I want just 90 degrees, nothing is going to work. I mean, it's going to work, but not in the way you expect it, because let me just go to math is fun radians. Let me just look this up. And this is how radians work. So basically, you have to times it by math.pi because this is 180 degrees. Radians like you have it, so it's 180 degrees, and then you divide it by 2, and then you have 90 degrees. So that's how radians work. But thankfully, we have a helper from Three.js. I think we imported it earlier. We can just say use a magic number, we can say utils, what was it, I think degree to radians times 90, and this is going to work as you expected. And now let's just increase the Y position of the mesh because it's interfering with our plane. So for the sphere, where was it? It was right here. So we can go position, and then we can say Y, something like 4, and you can see works great. And then we can say receive shadow, cast shadow. And let me just see. And now we need to make our light cast a shadow, so we can say shadow. And this cast a shadow, but you can see there's a problem, it cuts off, and that's because basically I really don't understand it 100%, but I think the light itself is some camera, so you also have to adjust that. And also the shadow has an object, you can pass some options. So you can do that, you can say camera, and you can say top, and I found that this number works great. So you're going to see everything works as expected. And this is really awesome, now we can orbit around. Also, let me show you one cool thing. So your orbit controls, you can say auto rotate, save, and marvel at your first 3D creation. Alright friends, so now I have one huge problem, and that's basically right now I have no idea what's going on in the 3D space and what direction anything is facing. The changes we do are almost instant in the browser, but still, tweaking feels like guesswork and I want to spend more time being creative than just guessing numbers. You could use Blender to set up your scene and translate it to Three.js, but there has to be a better way inside the browser first before you have to learn some sophisticated 3D graphics software. Blender is a lot of fun though, and I recommend you learn it. Thankfully, Three.js provides a bunch of useful helpers, and I'm going to use the grid helper. So if we go to Three.js, let me just see, Three.js. Let me go there. So we can go to the documentation and let's say grid helper, and we can go here. And here's another valuable lesson. So how do you transfer Three.js concepts to Threlte? There really isn't a grid helper component inside Threlte. So how do you do it? And basically you can see right at the top, it extends line and object 3D, and that's the base class for everything in Three.js. And thankfully in the Threlte documentation, let me just find it. You can find object 3D instance. And what does it say? This component lets you use any manually instantiated object that extends free object 3D in Threlte. So you can use this to extend Three.js, and this is one of the most important lessons because you don't learn Three.js by reading the Threlte documentation, you learn it by reading the Three.js documentation. In this case, I'm going to add the grid helper so you can see a grid, and the axis helper so you can see the X, Y, and Z axis. And it's really simple. So let's go back to our project. And now I'm going to create a grid helper and axis helper. So I can say const grid helper. So just like in the Three.js code, we can say new. And from free, we can say grid helper. We can define the size 20 by 20. And let's create an axis helper. So we can say new free axis helper. And then we're going to give it the size of our grid. And I think this is a bit large, but let's just see. And then remember, we just need to use it. So on top of here, it has to be inside the canvas because that's where everything is going, right? From Threlte, you can say object 3D instance. And this sometimes happens, this weird thing when you import something, it randomly included in script. I have no idea why this happens, but yeah. So let me just close it like this, and then you just pass it. So you can just say object, and then for the first one we want the grid helper, which we just created, and then let me copy over this line. So for the another one you just use the axis helper, and then I'm going to save this now, and we're going to see we have our awesome grid and we have our axis. So this is the Z axis, the red is always the X axis, and Y is going to the top, and this should be 10, I think. So yeah, let me just do that, and awesome. But if you ever used a game engine, you're probably used to a GUI to control the values, and that's what I really want. And we could use the HTML input in Svelte and bind the value, but I don't want to build some UI myself, right? This is really tedious. And that's why I'm going to use the package tweak pane. So let me just go here. I'm going to say tweak pane, just so we can go to the website. And I wish there was a wrapper. I think there maybe is for Svelte. Basically, we're just going to quickly define some GUI, and then we're going to be able to change the values inside the editor. It's like we're using Unity or something, which is really awesome. So I can go here, inside the terminal. Let me just close this. And you can say pm I tweak pane. And we can also install the types, so we can say D types, we can say, actually not types, it's tweak pane core, and this is just from their documentation, right? So you can also install this, and then you can start the development server and go on your merry way. npm run dev, and basically this is it. Okay, so let me just close this, and let me just restart everything. Alright, now we need to do one more thing. Because sveltekit runs your code on the server and the client, we need to make sure we're in the browser context. So we can just do that by saying, let me just see, if browser inside our code, so we can say if browser, and this should auto import, so we can see if browser app environment. Let me just close that. And inside of here, we're going to write our code that needs to interact on the client, right? And then we can import the pane package, so we can say import pane from tweak pane. And then before I do that, let me just specify all the options for the sphere. So we can say const sphere, and then we can say position, and we can just use the same position as before. So X was 0, Y was 4, and Z was 0. Okay, so now we can use these options for the sphere. Let's go to the sphere. Yeah, so here was the sphere, and instead of this position, we can say sphere position, or you can even spread this option. So you can say sphere and give it the options you want, but yeah, let me do that, and then I can save this. And now in the browser here, if I go, so I can just define, we can define the panel. So I'm going to say const pane, we can say new pane, title scene, and this should be added GUI to our scene, which is really awesome. So now I'm going to add a folder, and this is optional. I'm going to say const sphere controls pane, add folder, so everything is neatly organized. And I'm going to say title is going to be the options for the sphere, and now we can use the sphere controls to add an input. We can say sphere controls add input, and now we can say the object, and this is really neat. We can just say position, so it's going to take the key position and display it. So if I save this, awesome. Now we need to listen to some changes, so you can do that using .on, and you can listen for the change event. So inside of here, we can say sphere controls on change, and now we get back an event. And now let me just log out the event. So I'm going to Control I, open the developer tools. And now when I change anything, is going to see an event is going to get logged out. So all the values and etc. And what we want to update position, and when we update the position, because it's Svelte, right, is going to get updated in the browser, which is really awesome. So let me just remove this line, and here, where is the event, we can just destructure the value from this. We don't need the entire event. And now we can say sphere position value, and I don't really want to deal with TypeScript, so we can just say value as any. Now we can do this. Let me just close the developer tools, and now I think everything should work. So we can just, awesome. We can just move our mesh. You can see here some problems with shadows, but you can increase that if you want. But this is so much nicer, in my opinion, than having to just guess numbers and etc. It's like you're making your own game engine, which is really cool. The last thing I want to talk about is where you can get free 3D models and how to import them. So the site I love for that is Sketchfab, and I'm not sure about you, but I'm absolutely in love with these dioramas. So if you're unfamiliar what a diorama is, it's basically like these self-contained pieces of art. Like you can see it like this, and I think it looks really cool, and this is what I wanted to replicate. But basically, when you search for this, you have to press downloadable, so it filters by that. And you can download the free ones where there isn't this $sign. So that's going to be completely free. And there's a lot of 3D file formats, but the one you want is GLTF or GLB. And basically that stands for Graphics Language Transmission Protocol. I know it's a mouthful, but yeah. Basically, what it means is this is the best format for working with 3D on the web. So it's more efficient than something like FBX and etc. You can download that. But I often find the problem with GLBs from Sketchfab, they convert it for you automatically. So maybe that's not the original one the author created. So in that case, you can just download and maybe learn how to use Blender, which is an awesome open source and free 3D tool. You can download that and edit the model easily, change whatever you want, and then you can export it. And I'm going to show you a bit of that in the next section when we're going to make the spooky scene. But yeah, to use the model inside Threlte, let me just find the section. It's GLTF components, so let me just find that. Yeah, here it is, GLT, and you can see you can import, in this case, this helmet. So here's how the code looks like. It's just the GLTF component, the URL is the path to the model. You can put this in your static folder / models or whatever. And that's how simple it is to import a 3D model in Threlte. And also these models come with animations. So if I go to the use GLTF animations hook from Threlte, you can easily control animations using this hook. So if we see the code, here it is. So GLTF, use GLTF animations, and then you can take the animation that's exported with the model. But yeah, there's like basically so much to 3D, from learning about 3D itself, Three.js, game development, even some basic math, right? But yeah, I hope you're excited to go on this journey, and I think it's really fun. Before we start working on the spooky scene, I want to quickly show you how you can edit models in Blender, which isn't intimidating, and I have no idea what I'm doing in Blender. Everything I learned was from searching, and if I can figure it out, you can. But of course, I don't expect you to follow this because I'm just going to show you quickly how you can do it, and the models are going to be, not here, they're going to be in static. So you can go here, models, you can get the models, and you're going to get the same result as me. And yeah, let me just show you. So inside of Blender, normal, like all other software, left click to select items, really nothing special. If you know that, you can figure other things out. You can press A to select all of items and delete to remove them. So in this case, I downloaded that cute ghost from Sketchfab, but there was something wrong with it, right? And I just downloaded the original FBX file like the author intended it. So you can say import and just find FBX. And here in downloads, I had a cute ghost. You can go to source and just find the FBX file. So you can just scroll in to zoom it out, and in Blender you can hold Control and yeah, zoom in. So I don't really want this background, so I just left click it and delete it, easy like that. I don't care about these pumpkins, which can be cool also. You can export them separately, you can animate them so you get spooky pumpkins. I'm just going to remove that. And there's some weird things also with this ghost. They're like 2 layers. I have no idea what's going on here even. But yeah, we can just click on the mesh after I selected that outer layer because I have no idea what it is. And then to get into edit mode, you press tab, and let me just zoom in. So now you can, let me just press tab, you can select one vertex, this is called a vertex, right? And then you can press L on your keyboard to select everything that's connected. And sometimes it's going to happen this if you're like me. And now you can press L and it's going to select everything connected. You can just press delete and let's say faces. And now that one is gone. And now we can do it for these other pumpkins. Let me just select a vertex from each one. Then I'm going to press L. And again, this happens because I think I accidentally select something from the ghost. Or I think it's because, let me just see. Or maybe because I'm close to the mesh of the ghost. Well, anyhow, that doesn't work. Just see. Yeah, just do it one by one. Really, it's not a big deal. Delete faces, because this is going to delete everything if you just say vertices. Yeah, this is interesting. Okay, so now L. Okay, and that's basically it. So now you need to fix the material, and let me just stretch this out. And here's the material tab. So here it uses some principled whatever, and you learn this the hard way. I removed this, I added some, let me see, what did I add? Diffuse, and that didn't work for some reason. But yeah, let me just say here. Then you go to the base color, and then you can just say image texture. And then you can just load it if you press here. And then inside the downloads where you had cute ghost, textures, just get the PNG. And now we don't see anything, but you can press Z on your keyboard and you can get to the material preview and you're going to get something like this. You can even see the rendered. And I don't remember which one I took. It wasn't principled. It was, anyhow, you'll find this out yourself, because when I selected the diffuse one, the material didn't work, and I literally looked up black material in Blender, and the person was using one of these other materials, and I was like, okay, let me try that, and wow, surprise, it worked. But you can just select that, and after you figure it out, and then basically that's it. You now edited your model however you want, and you can see, you can even make it lower poly to make it more efficient, right? That's also a topic in itself. And then you just go to here, and you can just say export, and then you can say GLB. And let's just do it inside downloads, and let's just name it ghost or whatever. And now here, I've seen in other examples, there's like a compression option, so you can use, there's this thing called Draco, which can compress it for you, but I don't really have this option, so I don't know what's going on there. But yeah, to reduce the size even further, you can go to Geometry Material, here where it's import, because this is going to be basically one file. GLB has all the textures and everything baked in for you. And for the images, you can select JPG, so you get the most compression, and then you can just say export it. And another thing I like to do, so let me just say Three.js editor. Now I like to go through the editor, and then let me just delete this mesh from before. And I like to say import ghost GLB. And you can see if something doesn't work here, then go back to Blender, you can select the material, right? Okay, so basically what the problem was, I think it had some other settings, right? So I removed this thing entirely and basically I re-edited it, and now you see it looks normal. So let's try doing that again. We can say export. If I can figure it out, you can too. And let me just import it. And you can see, awesome, it works. And now when you import it in Three.js, you know it works. Okay, so basically that's it. Let's take everything we learned so far and create a spooky scene. So I left all the imports we're going to need and the grid helper and the axis helper. So let's start first by creating the camera object. Inside of here, I'm going to have some options for the camera. Let camera, I'm going to say position 10, Y is going to be 10, and Z is going to be 10. And then since I'm going to use an orthographic camera, I'm going to say zoom 40. It doesn't have a field of view because an orthographic camera ignores the size of the object if you zoom in or out. It's always going to be the same size, and because we're using a diorama that's basically isometric, it really doesn't make sense to use a perspective camera, but you can, and it looks great the same. And then I'm also going to have a point light, so I can say point light. This is going to be the illumination for our lanterns. So we can say x0, and y is going to be 2, and z is going to be 2. And then I'm going to specify a color yellow, so I can say HSL, because I always prefer HSL. It's going to be 100%, 50%. That's basically for the hex code in HSL. So that's for a point light, and then I want to define a ghost, so I can say ghost. I'm going to say position, x is going to be 0, y is going to be 1.9, and z is going to be 0. But of course I already know this in advance because I've done it, right? And then we need to scale the ghost down, and that's basically all we need for the scene: a camera, a point light, and the ghost. Spooky. And I'm going to do one more thing, and you're going to often see this in tutorials where they change the scene settings or whatever, and one way to do it, how Svelte exposes it to you. For example, I want anti-aliasing because otherwise objects are going to have sharper edges, so I really want to smooth that out. So you can say render parameters, and you can say anti-alias true, which is false by default, I think. So I'm going to add a camera, Svelte, and this time I'm going to add an orthographic camera. And then remember, I'm going to use orbit control, so I'm going to do this, and I'm going to say Svelte orbit controls. And remember our object, the camera, we specified before, we can just spread it here. So you can say camera. And it also helps if you spell orthographic, right? Yeah, and let me just see. Yeah, because we need to update it here too. And now it's not complaining. And also now we have an isometric perspective, so you can make an action RPG if you want. Sweet, so let's add the models before we add the light. So I can say, let me just give us space to work with. So the GLTF component is coming from extra. Not like this, extra, GLTF. If I scroll up, here it is. Oh, actually, I need to import it, yeah. So after free, we can just say import all as extra from, I guess that's Svelte extras. So that's where that comes. Let me just move that up. And now it's not going to complain. Let me just close it out like this. And now we just need to specify where it's located. And in our case, the model is located in models, and Vite is going to do the importing, so you don't have to specify the entire path. It's going to look in the static folder. In the static, let me just show you. Oh, here it is. In the root of our project static, models, here is the garden and the ghost files. But yeah, so we can say models, ghost GLB, and then we can just spread the props for the ghost we defined, right? We just save this. And now we have our spooky ghost, but we have no lights. But yeah, let me just add another one for the garden. Say extra, not like this. Extra gltf URL, and then again we can say models, garden, glb. And this is it, we really don't have anything special for this. And now we're going to add some lights. I'm just going to have an ambient light and a point light, so I can go here, Threlte, ambient light. I'm going to give it white for now so you can see what's going on, and I'm going to say, actually let me just save this so you can see it's lit. And then if I increase the intensity, it looks like a day scene, right? So how can we make it look like night? We just need to pass it blue. And now it looks like night. Ooh, spooky. And now let's add the point light. So we can say Threlte, point light. Just close it. I'm going to lower the intensity. And then remember, we already defined point light above, so we can just spread the object. And this is going to illuminate the lake. So we can see here, for example, if I made it 2, it's going to illuminate everything. But yeah, I just want it to be subtle. Alright, so now I want the ghost to float, and how can we do that? We can probably use Svelte's twinned motion, but let's do it the game development way. So we're going to use the cosine and we're going to make it float, and I'm going to explain how that works. Let me just see, I'm going to go here and let me just define a function. So we can say function float, and we can say time in seconds. So we can say date now, we get the current time in milliseconds, and then we're going to divide it by 1000 so we can get seconds. And then this is just an offset because I don't want the ghost to clip the terrain. And now what are we going to do? We're just going to update the ghost Y, so we can say ghost position Y, and then we can do our magic. So here we can say ghost position Y, and remember, because it's Svelte, is going to update. So this is how it's going to work. So we can say math sign, and this is going to return the sign number in radians, time in seconds, and I'm going to use the offset that we defined before, and then I'm going to use request animation frame so I can do this animation, and then I'm going to pass the float function in, and that's just going to loop forever and our ghost is going to float. But now that we say, nothing is happening because we need to call it. And since I'm going to already use the browser, let's just say if browser, you don't really have to do it, you can just define this outside. We can say float. Now we're going to see our ghost is floating. Ooh, spooky. But how does this really work? I just want to take a minute to explain this. So let me just math cosine. I think this is it. Okay, so you can see here is your circle, and the red one on the x-axis is going to be the cosine, and the green one is going to be the sine. So you can see it always starts at the top. Let me just refresh this so we get the animation. So you can see how this works and the ghost is floating. This is really showing how the sine works. And I really think this is cool. You can even see it in this spring animation. So here it's the cosine, which is really cool. Just some basic math, right? And you can see the sine starts at the top, but you can use cosine to start from the bottom. So if I go here, and let me just, instead of math sine, we can say cosine, and you can see the ghost floating is going to start from the opposite direction. From the top in this case. And that's basically how cosine works. And this is just some basic trigonometry, like, so this is the plot of sine, plot of cosine, and I really suck at math, but this is like really super fascinating to me, and I learn more about it each day. So I hope you also appreciate me explaining how this works, and I hope it makes a lot more sense. But yeah, let me just close this now. And also, same as before, let's add some controls for our thing. So we can say camera controls, and we can give the point light controls and for the ghost, right? And you can probably turn this into a component, which would be better. You can even loop over this, but I really just want to make it as simple as possible and not complicate things. So here we have float. I'm just going to say again as before, const pane, new pane. We can say title, scene, and if I save this, you're going to see a new pane. And I'm going to say const camera controls, and then I'm going to add a folder, pane, add folder, and I'm going to give it a title camera, like this. And now we can say camera controls, add input. We can pass it the camera object and the position property. And then let's just copy it over like this. You can say add input, again camera, but this time is zoom, right? Let me just save this. And now we have our X, Y, and Z position and our zoom for the camera. And now we need to update it, so we can say camera controls on change. We get the event back, but we can get the preset key, which is going to be the key from the object, and the value. Let me just show you. So I can say preset key, and you already seen the value before. So let me just hold on. Yeah, I need to wrap this like that. Let me just see. I need to do this. And let me just save this. Let's see, what is it complaining about? I need to close it here so we can do that. And everything should work as before. Awesome. Okay, so now let me show you a cool trick. So we can do that. And now we can see position. So it's doing that. And here's the zoom for the camera, which we're also going to log, right? And now since we know what the key we're doing, so we get position zoom, and now we can just do it on the object. So in this case, let me just remove the console log. So we can say the camera object, and we already know the preset key. So we can say preset key, and then we can set it to the value. And that's basically it. So let me just save this, and TypeScript is complaining, but don't worry about that. And now when I change the position of the camera, you see it's working. And how awesome is this? You can use zoom in, zoom out. And let's just please TypeScript. So let me just create some types here. You can ignore this if you want. So basically I'm going to be lazy. I'm going to say type camera key of type of camera. So it's just going to give me the keys from the objects, and that's the only thing I care about. So TypeScript isn't mad. And now I'm going to say point light. I'm going to say point light. And I'm going to say ghost, right? Ghost key of ghost. And now I can use this. So here we are with the camera. So we can say as camera, so TypeScript is happy. And then for the value, because I don't care right now, we can say as any, and that's basically it. So this is going to work as expected. Okay, so let's copy the same thing for the point light and the ghost. So I can go here, I can press camera controls, and then we can just press Ctrl D to select everything, and point light controls. So let's see, we can say here point light. And the point light is going to have a position, but it's also going to have a color, right? Because if we go here, instead of camera, this is going to be position light. And we also get great TypeScript completion here. Not position light, point light. Yeah, we can save this. And now we can see here we have the controls, but we have to update the point light controls on change. Instead of camera, we can just say point light as point light, and this is going to work. So now let's change it to a spooky red. Awesome. You can see it barely changes, but it works. And you can see we can change the position of the light. And how awesome is that? Okay, so let's add it again for our ghost. So we can say point light controls. Copy this over. Again, Ctrl D, we can say ghost controls. And then we can say ghost. And let me just pass it ghost. We won't have a color. Our ghost is going to have a position and the scale, I think. See if we can get auto completion, scale. Awesome. And now we can do the same thing. We can say ghost. Ghost. And now if I save this, now we can maneuver our ghost. And let me just stop the animation. And this is how you would do it otherwise. So you can go here, and now we can position your spooky ghost however you want. You want it like this. But yeah, and then you have to take these values, of course, and apply them in your project. And there's maybe a better way to do this, but yeah, so far it's really awesome. And now I can enable back the floating, and we get the spooky ghost. Let's also add some post-processing, and you can do that easily by using the bloom effect, which is infamous in video games, but we can basically do it. If I go here, and then we're going to say, let me just do it here. So I can say Threlte, and you can say pass, and you can do it like this. And now we're going to say pass, and we're going to do new Unreal Bloom pass. Like this, and let's make sure that this is imported. So if we go at the top, let me just see utils. We can say import Unreal Bloom pass from, so this comes from Three.js, examples from the ESM modules and post-processing. But yeah, now you have this, and let me just go here. Now we have this. So basically you can learn this from reading the documentation, but I'm not really sure on this one because we can see what it requires. It requires, let me just see. Can you get some auto-completion? Oh, maybe not. New Unreal Bloom pass, but yeah, let me just new 3, this is what it requires, vector 2, and I really didn't find that any value I put in makes a difference, so I just give it 1, 1, because I don't know if it wants the ratio or the height, but yeah. And these are the numbers I find that were great, so I can say 0, 7, and of course it helps if we close it. And then let me just save this, and you're going to see, oh, so that's why we didn't have auto-completion, because I didn't complete the import. We have to go, so yeah, you have to go to post-processing, and then you have all of these effects. So we can say Unreal Bloom pass. And here I can go where we were before. So yeah, so when I'm going to save this, you're going to see the bloom effect. And how cool does this look, right? So we can see the ghost even blocks the light, and it looks really pretty. Another downside of this bloom pass is that it ignores the HTML background for whatever reason, because there's some bug with the opacity. I'm not really sure, but we're going to fix this by defining the background color on the scene itself. This is another cool lesson how you translate Three.js concepts to Threlte, because Threlte gives you a useful hook for hooking into the scene, but the downside is, or not downside, but you have to use it inside the canvas because it's going to hook into the context of the canvas. Yeah, let me just go to Threlte. And let's just find it here. So it's going to be use. Let me just see. Here are the hooks. Yeah, use Svelte, and this is going to hook you into the scene. But yeah, to do that, let me just create a background component. So in source routes, I'm just going to say background.svelte. Now for the background component, create a script, and I'm just going to say again import all as free from Three.js, import all as Threlte, so you can say Threlte core, and then we're going to pass it a color, so we can say export let color, and the type is going to be free color representation, and then we can grab the scene from, again, not from, but equal, we can say Threlte. Svelte. Since I'm already using this convention, I'm going to stick to it. Yeah, let me just do this. And then when we're here, we're just going to say, hey, scene, background, and then you're going to set it to the new Three.js color. So you can do it like this, and then you're going to pass the color. And that's how you figure it out. And how I figured this type out, I basically hovered over this, and this says that this is free.color representation. That's how I know the type. Okay, so we can save this. And now inside of this canvas, let's see, after the pass, sure, we can go here. Then we can start typing background, and this should auto import the component for us thanks to TypeScript. So let me just see, make sure, yes, here it is. Let me just put it here, and we really don't need this. We goofed it up before. Yeah, so here is the background, and now inside the context, so it's going to get the values from the context of our scene. And now I'm going to use a spooky Svelte brand color, orange red. So I'm going to do this and see control space, we get the color, and let me just say orange red. Actually, this is a string, so I can just do it like this, and I can save it, and now you bypass this bug, and this is really awesome. And that's it for a spooky scene. Alright, so that's it. I hope this is just the start of your journey into 3D, and I encourage you to learn some game development with Godot. So you can look at Godot, it's really lightweight, it's free and open source, and you're going to learn a lot, I'm sure, and have a lot of fun. And if you're mathematically challenged like I am, I highly encourage you to watch Math for Game Dev by Freya Holmer. She's amazing. You're going to learn more in 1 hour than you've learned in years of schooling, and math is going to finally make sense to you, and you're going to understand what it's useful for. But yeah, that's it from me. Thank you for watching, and catch you in the next one.